Hello again. In this video, I'm going to go over section R3, objective 5, which is about multiplying radical expressions. And so I'm just going to show you a couple of examples here. So suppose you want to multiply the square root of 6 by the square root of 10. Now the way we're going to do this is we're going to take advantage of this property here, which says the nth root of a times the nth root of b is the same as the nth root of a times b. Now notice the index here and the index here have to be the same in order for you to combine them under one radical. But that's the case here. These are both square roots. So you can combine this under one radical and just say it's the square root of 6 times 10. And of course, we're going to break this down into its prime factorization. 6 times 10 is really 60, but we're going to break it down into 6 times 10 anyway. And then 6 is 2 times 3, and 10 is 2 times 5. And so in terms of its prime factorization, 60 is 2 squared times 3 times 5. Okay, so I'm going to write it that way. So we're going to take the square root of 2 squared times 3 times 5. And then we can break this up into 3 different square roots using this property again. So this is the same as the square root of 2 squared times the square root of 3 times the square root of 5. And now notice you can actually simplify this. The square root of 2 squared is simply 2. And then you can multiply these together under one radical using this property again. So the square root of 3 times the square root of 5 is the same as the square root of 3 times 5. And then that's just equal to 15, so it's really 2 times the square root of 15. Okay, so that's how you would multiply these radicals together. And then this would be in simplified form. Okay, so let's try part B. So in part B, the first thing I'm going to do is rearrange the order in which I multiply these. The order in which you multiply doesn't matter. So I'm going to multiply the 2 and the 5 together first, and then the 2 radicals next. Again, all I'm doing is changing the order in which I multiply, which is perfectly fine. Okay, order doesn't matter when you multiply. Like 2 times 3 is the same as 3 times 2. You can change the order of multiplication and you'll still get the same answer. Okay, so obviously that's 10, right? 2 times 5 is 10. And then we can combine these under one radical since they have the same index of 4. So it's the 4th root of x cubed times x to the 7th. And here, of course, you would add exponents, so it's really x to the 10th, which makes sense because there's 10 x's here. But then since the index here is 4, I want to break this up into as many x to the 4th as I can. So I am going to write this as x to the 4th times x to the 4th, which is 8 x's. There's 2 left over, so then that would be times x squared. And then using this property again, I'm just going to break that radical up into 3 different radicals. And so I'm going to take the 4th root of x to the 4th times the 4th root of x to the 4th times the 4th root of x squared. And of course, each of these are equal to x, right? This one and this one are simply x. So you get 10 times x times x. And then this one, if you remember, this is not considered simplified because it has a factor in common, a factor of 2 in common. And so the way we handle that is you can write this as, remember, you can write this as x squared over 2. Oh, sorry, x squared over 4. So the exponent is 2 and the index is 4. Right? The index goes on the bottom and the power goes on top. And then these cancel. They have a factor of 2 in common, so you can write that as x to the 1/2 power, which is the square root of x. Okay, so this is simply the square root of x if you reduce it, and this becomes x squared. Okay, so that's how you would multiply these two together, and then this would be the simplified answer. Okay, so I hope you found this video helpful. Thank you for watching. Bye-bye.